This is a project I built that is a clapper made out of an Arduino, an op amp, and a simple circuit. Whenever I clap twice, it turns this LED on or off. This is my circuit diagram that I used to build the clapper. I measured my microphone with a voltmeter, and the max it puts out is 1 millivolt. Therefore, I needed a 5000 gain in order to produce a maximum of 5 volts coming into the Arduino, which is the maximum it'll read from the analog input. So that's why I needed a op amp to get that 5000 gain. And it's a non-inverting op amp circuit, so I used a 4.7K resistor and a 1 ohm power resistor to build my op amp circuit. So I'm getting a gain of 4,700, which is as close as I could get because I don't have a 5K ohm resistor or a working potentiometer at the time. So you can see that it comes out of the op amp and goes into the Arduino, and the Arduino writes a digital pin high or low through a 330 ohm resistor to an LED into ground. This is the Arduino code that I use for my clapper. Here are the declared variables first. You can see that sensor pin is set to the first analog input pin. Sensor value equals 0, that's the analog value of the sensor pin. I equals 0, that's just a counter for my loops. LED pin equals 4, that's the digital pin that's going to write to my LED. And then there's pin and pin 2, which are counters that I'll explain later. In the setup, I have the baud rate set to 9600, and then I have LED pin equaling an output so it can write to my LED. And in the loop, I have sensor value equals 800 first. This is to make sure that each time the loop goes around, there is not a previous sensor value stored from the previous iteration of the loop. Then I have sensor value equaling the analog read of sensor pin, so that stores the analog value in sensor pin. And if I also digital wrote the LED pin low just to make sure from a previous iteration of the loop it's not still high. And I initiated pin and pin 2 equals 0, just again if the previous iteration of the loop was equal to 1 or something like that, it's going to reset them both to 0. So then I'm printing to the serial monitor the sensor value and a space, and then there's a 50 millisecond delay. And the first if statement, if the sensor value is less than 720, so this is the analog value is less than 720, then it's going to delay 100 milliseconds, and then the for loop is going to initiate. It's going to do 20 iterations of 15 milliseconds apiece, and it's going to look and see if the value of the sensor value goes under 720 again. If it does, then it's going to increment pin 2. And then you can see after the loop goes through, if pin 2 is greater than 0, it's going to increment pin and delay 200 milliseconds. Then if pin is incremented, if it equals 1, then it initiates this while loop, which it's going to, if the LED pin is already high, it's going to skip, but if it's not, it is going to write the LED high. And then it just goes through the same process again, and that is for off. It digital writes off instead of on though. And there's delays, and I initiated everything again, like you can see here, sensor value equals 800. Those are all just for debugging, so in the previous iterations, if there were values already in these variables, then it's not going to carry over. Now to show you what I'm talking about a little bit better, I'm going to go into the serial monitor. The default value for silence is 750. I could get that a little bit higher with a potentiometer, but this was kind of a quick and dirty build, so I'm leaving it at 750. Just as you can see with me talking, it's pausing. Every time it pauses, it enters that for loop that's doing the 20 iterations of 50 milliseconds apiece, and it's trying to find another sound under the 720 value. So now I'm going to clap, and it paused. It's looking for it, but it's not going to turn the light on because it didn't get 2. Now if it gets 2, it turns the light on. There's a few things that I need to do to make this project a little bit better. Right now the analog input for silence is sitting at 750. It really should be sitting at around 1000. So I need to either put a potentiometer on the resistor, the 4.7K resistor, to get the resistance up and give it a better gain, or run it through the op amp twice so it has 2 op amps in series. Also, this microphone was only $7 at Radio Shack, so I don't think it's got the best quality. And lastly, in my code, the sampling of 50 milliseconds, looking for a clap every 50 milliseconds, is possibly inaccurate. I need to look at an oscilloscope with my microphone and see how long a clap actually lasts. It could last less than 50 milliseconds, so I could be missing claps. But aside from all of those, it still works pretty well, so I will keep working on it, and I'll make another video when it's perfected. Thanks for watching. If you have any questions, leave them in the comment section below.